All right, let's talk about what's going on the rest of the term, the rest of the semester. Sounds scary. Okay, today you should have done 6.6. If you haven't, you still can do it whenever. Everything needs to be done by the 15th is the last day for work submission for this term. So make sure you've got it going there. We are going to actually do a lab today, what we'll call stoichiometry. There is a new activity? I don't think so. Let me look at that, and I'll look at your daily 6.5. We're going to do the pre-lab together. So hopefully by the time you're done with the pre-lab, you're ready to go to the lab. And you should have time after lab to finish it up and to do your near-pod activity to do that. Okay, so I'll check in on that while you're doing lab. So let's look at the lab paper to start with, the oxidation of iron wool. The stoichiometry lab. We will be taking and oxidizing iron. And we're trying to figure out what we're going to make. Are we going to make iron 2 oxide? Are we making iron 3 oxide? Are we making iron 2 3 oxide? Or are we making iron 4 oxide? So we're trying to figure out what we're making when we make this reaction happen. Okay? So pre-lab, first thing I want you to do is take a few seconds here, balance these equations. And I'll pull people up to help me write it in. Okay, how we doing? We got it done?
I know I remember this. I felt like I should remember all out of it. Oh yeah. And you told us that we.
Okay, looks like I'm going to have to do this. For some reason, my board's not writing. So on the first one, for A, let's see. For A here, what would be in front of the FE? Okay, we put a 2 in front of the FE, and then in front of the O2, what do we put? So we don't write it. And what do we put in front of the FeO? 2. Okay, what about B? What do we put in front of the FE? Okay, in front of the O2.
3.
And in front of the Fe2O3. Okay, so we missed something.
4.
4, there we go. Okay, on C, we've got Fe plus O2 gives us Fe3O4. What do we put in front of the Fe?
3.
What do we put in front of the O2?
2.
And one in front of the Fe3O4? Nothing. Okay, and on D, what are we going to end up with? Nothing. Okay, so it's just going to be the Fe plus O2, Fe2O3. All right, I'll tell it that way. Okay, now I'd like you to add up the masses of these really quickly. Fe has a mass of 55.845. Oxygen has a mass of 15.999. So quickly add those up for me.
What if we use the 2 in,
Oh, you've got a 2 here? Go ahead.
okay.
I just memorized 5 significant figures. So. Okay, somebody got A? $71.845. B? B's what? Did I put that right? Okay. And C? How fast you can go. Nobody's brave for C?
87.843.
It's gonna be more than that.
Oh, I didn't have calculation.
Okay, do I have a second on that?
Oh, steam.
Okay, I got D. Okay, so these are what we're going to be using later. So that's why I wanted to make sure we had them. So if we go to this other side, I bring this over.
A should be 71.844.
Yeah. A should be 71.844.
Yeah.
Okay. All right, now, looking over here, we're going to set it up because what we're going to be doing is when we get back in the back, you're going to take a mass of still wool. It should be about, I believe it says at the bottom here, about 5 grams. So you're going to weigh a small beaker. We're going to just use a weigh cup, so it's not really going to be a beaker. You're going to weigh a weigh cup. You're going to weigh about 5 grams. Okay? Doesn't have to be exact, but you do need to write the weight down. So record the mass of the still wool in the beaker. So the beaker is going to be, again, the weigh cup. So the weigh cup plus 5 grams, and then subtract the 2 to get the weight of the still wool, and that should be about the 5 grams. Okay? We're going to start each of these conversions here on this next one with that weight. We don't know what it is right now, so we're not going to fill it in, but we're going to set everything else up. Okay? So if I bring this back right here, and I'm going to keep coming back and forth to it, and I wish I could write here, still won't let me. Okay, it's going to try and fill it in. So I'm just going to slide, whoops. I'm just going to have to come back and forth. So I'm going to get me another page here, and I'll come back and forth between the pages. So on the first one here, on A, we will have started with our grams of Fe, but we don't know what it is right now. So I had it set up here for you. Okay, if we look at here, grams of Fe, we want to go to moles, and then we're going to use the equation to go from moles of one thing to moles of something new, and then we're going to go to from moles to grams, so we find out how much we should end up with. Okay, so coming back here, I'm going to put the mass of Fe on the bottom. We've already known that it's 55.845. If you want to use the 2, you can. Grams of Fe. You're going to have to write skinny because you're going to have to get 3 conversions in here. Okay, on the top, I'm going to put 1 mole FE. That is gonna be the same for all three conversions. That first conversion, all the same. Because we gotta get it into moles before we can change it with our equations. Now, for A, I'm gonna come back here to this equation, and I'm gonna say, oh, for every 2 FE, I need 2 FeO. So coming back here, I'm gonna put 2 moles of Fe for every 2 moles of FeO. So again, as I'm going, I'm going to be able to cross out what I have. The last one is going to be number 3 up here. I'm going to go from moles to grams. Well, we've already added that up. For A, it was 71.844. So I'm going to put on the top 71.844 grams of FeO. On the bottom, I'm going to put 1 mole of FeO. That's going to cancel out. Now, all I have to do is when I get back to lab, plug this in, and I can find out how much I should be able to get. Okay? So, I would like you to try E, C, and D on your own using this as a way to figure it out. But on the next one, you're going to use equation B and the weight of B. Okay? So see what you can do. I'll start here in a minute. This was A. I'll do B here in a minute. If you're totally lost, you can go with me. C and then D. So we're all going to have the same stuff. So see if you can figure it out, because you need to be able to do this on your own. This is a review. Trying to get your brain back in gear after holiday.
Answer?
What?
To plug the answer in. I mean, you want us to plug that in and find the answer?
Once you get in the lab, because right now we don't have this first number. So it's however much you weigh out.
Oh, the still won't?
Yeah.
Oh, okay.
So we don't know that. We're just setting it up. So when we get there, we can find it fairly easy. It's hard to do small when you don't want to write. Lovely 3 there. Okay, how'd you do as far as setting up? Okay, so hopefully this is all set up. All you have to do is plug in that first number that you're going to get in lab. Okay? Once you've got that, then you can plug through and find out how many grams of each of these you should end up with. And that's if the reaction goes fully. If the reaction doesn't go all the way, you're going to end up with less than that. Okay, and then you've got to say, okay, I ended up with less than that. Which one makes sense? Okay, so going forward here, you're going to clean around your Bunsen burner. We haven't done a lab. You're the first one, you're the last one, because I only teach one chemistry. So your Bunsen burner area should be clean. There is stuff for CD chemistry in a basket. Don't touch it. You need the burner, you need the striker, and you need the tongs. That's it. So don't touch any of the other stuff. You want to keep your burner in the center area of the clean area, okay? Because when you burn the still oil, it's going to fly. Having said that, you're going to want to wear the black aprons because they're rubberized, and if things hit it, they just bounce off. If you don't and you wear the cloth, it's going to bounce and cause holes, okay, because it's going to be fire. I like this one because it's the beginning of the year, it's sort of fireworky and it's sort of fun. Okay, so you're going to carefully weigh out your still wool, and then you're going to get tongs. And you and your partner are going to basically fight over the still wool over the fire. And it's going to throw sparks. So you want to try and I call it belly up to the bar. You want to keep the sparks on top of the table. Because anything that falls off is weight you lost. Okay? Your ending product needs to weigh more than your beginning product because we're adding oxygen to it. If it doesn't, you've lost. So you've got to go back and try and figure it out. Okay? You're going to burn it over the flame. You're going to pull it apart. You're going to blow on it. But as you're doing it, don't pass out by blowing too hard. Don't blow the flame out by blowing too hard. But you do need you want to put oxygen into it. Okay? So you want to put more oxygen than normal. I usually have them do it with a straw. We ended up with a lot of spit, and I just done with that. So just blow into the flame, and you'll see it'll start to glow a little bit more because there's more reactions taking place. When you're all done, there's going to be powder. There's not going to be a piece big enough for you to pick up with your tongs. You're going to want to take a piece of paper back there, or you can use your thing, and you're going to want to just scoop it with your paper, do not use your hand. Why? It won't be hot.
Because they'll stick to your
It'll stick to your hand and you won't be able to get it off. And then you've lost weight. With the paper, it doesn't have the extra moisture, so it won't stick. So you really have to scrape it into a pile and then scrape it into your container. Now, I put the scales, the scales on the front and the back, because I don't want them on the tables, because if the sparks are flying, they're going to end up messing something up if I leave them there. So take and weigh. Don't clean up your area until what you have weighs more than what you started with. That's really important, okay? Because you can't have a -% error. You can have positive, but not negative, all right? So once you end up with more, then go ahead and clean up your tabletop. You'll be amazed at how much you left on the tabletop. So you need to put that as part of your error. And I should have weighed more, and I really found a whole bunch. So really be meticulous about getting everything you can before you go to clean up. Because that's the biggest mistake I see kids. Oh, I'm over by 0.01, so that's good. Yeah, no. Okay? All right, so then you're going to weigh the beaker with the oxidized still. Make sure you're more, okay, than it was without. Then take the difference. This needs to be a positive number. If this is a negative number, you're in trouble. Okay? Then you're going to go back and whatever you figured those weights were on the front page, you're going to say, I think I have, and put an X by it. Then I'm going to have you take it through and say, if the real formula was C, I could have picked A, I could have picked B, I just picked one. Okay, if it was this, then you're going to go through and do an error analysis is basically what you're doing. How much oxygen was added? If that was the truth? How far off was I? How much didn't convert? So that's what all this is. And it sort of walks you through it. So read what it tells you to do and do what it tells you to do. If you have problems, then let me know. Then you've got an error analysis. What could have gone wrong? I've already told you. Okay. You've got a claim. What did you learn from this lab? What were we trying to learn on this whole unit? What's your evidence that it actually happened? And what's your justification? Okay. I will check into that Nearpod while you're back there getting this stuff going. All right? Questions? So we've done all the pre-lab together. We're going to head back. You do need a partner for this, so please make sure you're paired up. Say I have singlets here. I have a threesome there, I guess. So we're going to have one threesome. Okay? Those are short ones. Any questions? All right. Go ahead and, oh, we don't have a threesome anymore. Tino will be one. So, who's Tino? Partner. Where are you? Are you over here? Okay, so you two are still partners, right? And I'll have you be partners. Okay, all right, let's go back to lab. Make sure you put your hair back. There should be some ties if you haven't brought ties.
And then I checked in at the office.
What?
I checked in at the office. Is this what we need for the lab?
They should be in the little drawers. They're not real big ones, they're little teeny ones, but they stretch.
This is for the lab.
Oh, I forgot to shut.